In the last video, we considered Lewis structures and the charges we can determine associated with the elements in a Lewis structure. In this video, I want to discuss a property of molecules that becomes a central fundamental concept for the numerous reactions we cover in this course. For example, let's take the molecule CH4. Try drawing the Lewis structure and the formal charges associated with this molecule. The Lewis structure should look like this, and all elements should have a formal charge of 0. Remember the trend of electronegativity we learned before. Electronegativity increases to the right and up. Which of these elements in this formula is more electronegative, carbon or hydrogen? If you said carbon, you'd be correct. Since carbon is more electronegative, it's going to pull some of the electron density away from hydrogen. I like to imagine this as a super jacked dude playing tug of war against a super skinny dude. In the middle of the rope is a red marker. Where would that red marker hang out most of the time? Probably near the more jacked dude. The more jacked dude in this example is carbon. To show electronegativity, we draw an arrow with a line through it pointing to the element that is more electronegative. These arrows we can draw can help us determine a very important property of molecules. Polarity in chemistry is defined as a separation of charge in which one end has a more positive charge, while another end has a more negative charge, leading to a dipole across the bond or the molecule. If no dipole exists, the molecule or bond is considered nonpolar. Let's go back to our example. The arrows we drew seem to cancel each other out. I imagine these arrows as literal vectors. If two people equal in strength pulled on a box in opposite directions, or pushed on a box toward each other, would the box move? No, it will not. The same goes for this example. The bonds up and down cancel each other out, and the bonds left and right cancel each other out as well. Therefore, the molecule is overall nonpolar. Notice that it is absolutely possible for a molecule to have polar bonds, and yet be overall nonpolar. Let's take another example, H2O, one of the most important molecules to life on Earth. This is the Lewis structure for water. The Lewis structure has this shape because of certain properties we discuss later. For now, just take my word for it. Notice that oxygen is the more electronegative element, and the arrows point from hydrogen toward oxygen. Also notice the lone pairs do not exhibit any electronegativity, and so they don't have any arrows. In this case, the arrows do not cancel each other out, so the molecule is polar. Polar molecules have yet another property that is extremely important. Since oxygen pulls most of the electron density away from hydrogen, the oxygen has more of a negative charge. It isn't completely negative charged, but it almost is. We call this almost charge a partial charge, showed by the sign. The hydrogens, on the other hand, have a partial positive charge. Now that we understand bond polarity and overall molecule polarity, it's important to define a dipole moment. I mentioned earlier that polarity is defined as the existence of an electric dipole across a molecule. Therefore, if a molecule is nonpolar, no electric dipole exists, and the molecule has a dipole moment equal to 0. However, if any polarity of the overall molecule exists, then the molecule has a dipole moment of greater than 0. This concept becomes a central idea in the reason organic reactions work, so don't forget it. In the next video, we will discuss another property of molecules that stems out of the idea of polarity.